Good morning. On behalf of the Pembina Institute, I'd like to welcome you to part 2 of our webinar series, The Future of Hydrogen and RNG in Canada. I'm Karen Tam-Wu, the BC Director at the Pembina Institute. To start, I'd like to acknowledge that we're hosting today's event from the unceded territories of the Coast Salish, Musqueam, Squamish, and Tsleil-Waututh nations. We're grateful for their stewardship of these lands and waters since time immemorial. If you're meeting the Pembina Institute for the first time, we are Canada's leading independent climate and energy think tank, known for working together with governments, industry, and communities to advance a prosperous clean energy future for Canada. The potential for hydrogen and renewable natural gas, or RNG, to be significant contributors to the future energy mix is getting a lot of attention lately. In particular, their application in sectors that are hard to decarbonize through clean electricity. As interest grows, common understanding of the potential and the pitfalls of hydrogen and RNG need to be discussed so that we can thoughtfully consider their adoption in Canada. At the Pembina Institute, we're keen to move these important conversations forward. On behalf of the Pembina Institute, I'd like to thank the Canadian Gas Association for supporting this webinar series. We're also grateful to the Real Estate Foundation of BC, the Sitcom Foundation, and the North Family Foundation for their generous support of our work. If you'd like to support our work in this important area, please get in touch with us at pembina.org. Without further ado, I'd like to introduce Tara Jutt, Director of the Pembina Institute's Clean Economy Program in BC, who will moderate today's discussion.
Thank you, Karen, and thank you to everyone for joining us today for the second webinar in this series. Today, I'm joined by Hoda Talabian, Senior Analyst with the Clean Economy team, and Stephen Hui, who is producing this series. Both will be assisting with the webinar today. Please note the webinar will be recorded and will be available on the Pembina Institute website at pembina.org. We encourage you to share the recording with your networks. A few more details before we begin. All participants will be muted during the webinar. We'll have some time at the end to answer questions. Please use the chat box to type in your questions, and we'll do our best to get to as many as possible following the presentations. So let's get started. Canada must transition to low carbon and renewable energy sources to reach net zero by 2050. Emissions from the use of natural gas represents a significant portion of GHG emissions, and any solution to meet emissions must address the use of this resource. As we look to the full suite of energy options needed to reach 2030 and 2050 climate goals, RNG and hydrogen have the opportunity to play a role in the energy mix, especially in hard to decarbonize sectors or areas where electrification is not an option. Gas utilities are looking at innovative ways to incorporate low carbon and renewable gases as part of their product mix. Our speakers today will share their views on the potential for RNG and hydrogen and elaborate on programs and projects underway across the country designed to reduce carbon emissions and meet climate targets. Please join me in welcoming our speakers today from FortisBC, ATCO Gas, Énergir, and Enbridge Gas. Presenting today, we first have Scott Graham from FortisBC. Scott is the manager of renewable gas supply. Since 2009, Scott has helped shape almost every aspect of FortisBC's renewable gas program. He has deep industry knowledge and has contributed to the Canadian industry regularly as a member of working groups and as a previous board member of Canadian Biogas Association. He's a registered professional engineer and has an MBA focused on management of technology. Second, today we'll hear from Greg Caldwell, Director of Energy Systems and Innovation at ATCO Natural Gas Division. Greg's current focus is leading ATCO's development of a hydrogen strategy, which encompasses the technical, policy, regulatory, and economic aspects of the initiative. Greg is a registered professional engineer, and he also holds a CPA designation. Greg's professional experience consists of engineering, business strategy, finance, and regulatory policy in the energy industry. And his most recent experience has been focused on the area of business strategy, utility regulation, and energy policy, and applied innovation delivering low carbon energy solutions. Next, we'll hear from Vincent Regnault. Vincent is the Director of Gas Supply and Renewable Gases Development for Énergir. From 2014 to last July, he acted as Director of Transportation and Gas Supply. Before joining the gas supply team, Vincent practiced as a lawyer within the Legal Affairs Department for over 6 years, where he and his team appeared on behalf of Énergir before Quebec, Ontario, and national energy boards, as well as before various courts. Vincent is also Director of the Trans-Quebec Maritimes Pipeline, as well as a member of the Management Committee of Portland Natural Gas Transmission System. Before joining Énergir, Vincent practiced law from 1998 to 2008 with the national law firm in downtown Montreal as a member of the litigation team. And finally, we'll hear from Samuel McDermott from Enbridge. Samuel is currently the technical manager hydrogen for the renewable hydrogen program at Enbridge Gas's business development team. He's held several leadership roles at Enbridge, including engineering, project management, design, and customer service. He's a licensed professional engineer in the province of Ontario with over 25 years of experience in engineering and project management and in both manufacturing and energy sectors. Prior to Enbridge, he worked as a mechanical designer and project manager to develop highly specialized equipment for various industries, including in the automotive sector and the water industry. Please welcome all of our speakers today. We're going to begin with FortisBC, so please welcome Scott Graham. Scott?
Hi, good morning. All just a second here. There you go. All right, that's looking good. Yeah, of course. You can answer me. So for those of you who've seen me present in the past, this will be a huge challenge. You see, I love to wander across the stage and I love to pick on people in the audience that I know. So without further ado, I will jump in. I know we're short on time. Just a quick obligatory slide reminding you that FortisBC is part of Fortis Inc., a publicly traded company with gas and electric assets across North America. FortisBC itself, again, zeroing in on our beautiful province here, about 1.1 million customers. And I think really what I wanted to focus on this slide is remind everyone that we really touch a lot of people within the province. That dark blue section, that kind of T-bone shape, really comprises almost all the population within British Columbia. We have a lot of unused space in our province, but we deliver a lot of energy to a lot of different people and in a lot of different ways, including liquid natural gas, compressed natural gas for transportation. So without further ado, I'm gonna kind of launch into our vision of the future and what we've done to get there. And it starts with something we call the clean growth pathway. This is a chance for us as a company, as more and more pressure came over the last couple of decades to reduce carbon in our energy sources, we began scratching our heads and looking out to the future and what would a future look like. At the time, we thought without natural gas. And we started to really evaluate what is really best for our customers. What's the best way to, first of all, again, our obligation to keep energy costs as low as possible, to deliver that energy safely, and thirdly, to reduce emissions. So this is where we came up with this vision out to 2050 of something we call the clean growth pathway. And it's really based on 4 key pillars, which do translate to the 30 by 30. I'll get to that in a second. But really around energy efficiency, reducing emissions by encouraging more efficient use of our product. Global LNG, so that's the idea of displacing diesel in major vessels. And we're already doing it here in British Columbia. We're displacing diesel in ferries with natural gas and reducing emissions. Obviously, the zero and low carbon transportation, so electric vehicles is a no-brainer. And then there's also the idea of natural gas, again, compressed, displacing diesel. But today I'm going to zero in on renewable gas a little bit here. So it really contributes significantly to these 4 pillars. And just very quickly, 30 by 30, it's an easy way to remember, hey, Fortis is serious about reducing their emissions. We're looking at a 30% reduction in our overall emissions by the year 2030. So let's zoom right into renewable natural gas and its role in that 30 by 30 goal again, which is part of the clean growth pathway overall. We're looking at about 30 petajoules of gas in terms of our contribution to our emissions reductions. And that very roughly it translates to about 1.5 megatons of CO2 equivalent per year. And so this graph, don't get hung up on the dates or the fact that the lines are straight, but I really want you to take away from this graph that there's 3 sort of major steps in getting to this 30 petajoules. Okay, and what does 30 petajoules even mean? Does anyone even really know? Well, to put it in context, it's about 15% of our total gas supply in British Columbia. So pretty significant chunk of gas. And keeping in mind, remember, renewable gas, the beauty of it is that we're using existing infrastructure. We're displacing conventional gas with something that's lower carbon. Okay, so that means every gigajoule of gas we put in the system here is one less gigajoule of conventional gas we pull out of the ground. But this 30 petajoule number is our target. And we had an established program in British Columbia. I'll talk about that again in a sec. But there were some limits. Though we think using kind of existing technology today and what's out there, the existing feedstock, so organic waste, we think we could hit about 10 petajoules, which is about 5% of our total goal. So that wasn't enough. So we started thinking bigger and saying, okay, well, you know, really, we're putting gas in a system somewhere, we're reducing emissions by doing that. Maybe we could look outside the province. So we felt like we started to expand the scope of where we could get gas. And then lastly, this piece that's always there and that is this idea of advancing technology. And I'm sure you talked about it at length in the hydrogen webinar last week, but the hydrogen's a big name there. But I think I wanted to zero in a bit on wood to RNG, which I'll talk about a bit later as well. So this is just, I'll call it a little bit of it's a bit of a brag list, but at the same time, it's really just giving you guys an idea that we've been doing this for about 10 years. Okay, so we got a beachhead, if you will, into this industry by doing a very small program with 2 projects with 100% voluntary participation from our customers. And that was in the 2010-2011 era. We made the program permanent because of the success in around 2013. 2016, there was a recognition that customers, if they're going to voluntarily participate, need to have a rate that lines up with their expectations. So we did some changes to the rate structure, and that really led to a steady increase in demand and a spike to the point today where we have more demand than supply on a voluntary basis. So I don't want you to lose that notion that on a voluntary basis, people are willing to pay more for a product they think does something good. 2017, that's this 5% number comes from the government, something called the Greenhouse Gas Reduction Regulation. There's this little corner of it that talks about renewable natural gas, and it allowed us and other utilities within British Columbia to purchase up to 5% of our volume. So again, there's that 10 number that I talked about in the previous slide, 10 petajoules a year about. So we're gonna get to a bit of the challenges here, but ultimately that doesn't jive with what the Clean BC document said, and that was published in 2018, which wants us to get to 15%. So we have this 5% limit on what we can do sort of from a regulation perspective, but we have a 15% policy objective. So that's something that's really important here in today's discussion, and we'll talk a little bit more about that. Okay, so Fortis, you're talking big. Where are you at today? Okay, you think you can hit 30 petajoules? Show me the money. So this slide here is about that. Today, we're sitting on over 6 petajoules, so that's 20% of that 30 petajoule number. Approved projects, that's 20 different contracts from different parts of Canada. And, you know, take a look at that third column there on our potential. We think we're actually closer to somewhere between 20 and 25 petajoules, okay? So even if you kind of take a conservative estimate of 50% of what we're looking at for our prospects, we're sitting at about 15 petajoules, which is well above the current government maximum limit. So in fact, we're in a bit of a holding pattern this year. We're kind of saying, okay, well, time out everyone, we've got to settle down and not chase as much gas because we can't go beyond this hard limit in this regulation. Okay, so that's an important point. We'll get back to that again in a sec. I'm keeping a pretty close eye on my time here. Don't worry, guys. In 2020, there was a couple pretty unique things, and I already hit that first point, but we did in fact get approval to purchase gas from outside of our jurisdiction, okay? And the reason this works is the same reason we can inject gas in a city like Abbotsford and sell it to a customer on Vancouver Island. It's because it's about displacing conventional natural gas. Every gigajoule we put in is one less we take from the ground. We just keep track of it in an accounting mechanism to make sure by displacement, we're not double counting, we're not, that there's real reductions, all those kind of things. The other pretty cool thing is we have someone stepping up to the plate and saying, we're gonna do it. We're gonna do wood to renewable natural gas on a commercial scale, okay? So that's big. Okay, you talked about that. Again, I'm going back to my 30 petajoule number back here. If you kind of look at the wood waste available in British Columbia, okay, forget about competition and other uses and all that kind of stuff, but just look at the raw numbers, we could easily hit sort of the 80 petajoule number. So I don't want you to get hung up on 80 petajoules a year. What I want you to get hung up on is this is a bit of a game changer and a door opener for us. If these guys are successful, it means we have some big projects. It means there's opportunities to partner with other, with the forest industry and really find ways to make use of their waste product in our gas system. And of course, hydrogen. I'm not going to talk a lot about it, except to say we as a company are kind of phase one. We're really looking at system readiness, code, standards, safety. We're starting early discussions on looking for pilot and demo projects. Shifting gears totally. Fortis, are you walking the talk? Yes, we are. This innovation fund we got is approved as part of our regular rate making just this calendar year. Is that walk the talk? This is kind of a first of its kind. Now, again, among regulated utilities, other people out there have innovation groups. Other utilities have kind of innovation groups hanging off the side. But the idea of actually putting a little bit of money on the bill and putting that money back into innovation in British Columbia, that's what this fund is all about. And I want you to rest easy. We're not just, this isn't just pure self-interest. This is about moving the industry forward. We have solid governance, and we're expecting to see some projects coming forward this year. Last thought, I want to just kind of touch on it. Again, you saw we're bumping up against that 5% number. So that's a challenge. We think that the government needs to do a little work to make a change to that regulation. And we haven't kept it quiet. We are talking to staff at our Ministry of Energy. They're a great group of folks. The policy has to line up with the legislation. We've got to look at other areas to also find ways to move things forward. Like we talk about things like hydrogen, how does that fit in terms of regulations, code standards, that kind of stuff. So we're talking about innovating, evolving, developing, and ultimately some big dollars are going to have to go into some of these. So that's all I really have to say for now. I think I'm pretty close to my time. Thank you very much.
Thank you, Scott. Thanks for letting us know about some of the things that FortisBC is working on. Next, we're going to move to Greg Caldwell of ATCO and let us know what's happening in Alberta. Go ahead, Greg. Yeah.
Here we go. Now it's giving me an option of which monitor to choose. Okay, just hold on a second here. How about now? Now it should be good.
Yes, that's perfect. Go ahead. Thank you.
Thank you. I apologize for everyone on here. So I'd like to just quickly talk about ATCO and who we are, because I know we have members from all over, or attendees from all over the country. And so who is ATCO? We distribute, similar to Fortis, natural gas, except all over Alberta. We have 1.2 million customers and around 40,000 kilometers of pipelines that serve those customers. So most of the major centers within Alberta, if you look at the natural gas customers within the province, we serve about 91% of them. We also have a gas transmission system, and why I'm showing you this and why it's important is I'm going to talk a little bit about the difference between distribution and transmission system and how they're both important, whether it's hydrogen or renewable gas, whatever that low carbon commodity is that we're hoping to move in the future, how these things are a little different and how we're hoping to use them. So finally, we have about 9,100 kilometers of these transmission lines. As you can see, our infrastructure is really where most of the people are in Alberta, between Edmonton and Calgary. There's other pipeline companies that serve the rest of the province, such as TC Energy, for example. And we have 3,500 receipt and delivery points. So what that means is there's 3,500 spots where gas comes off of this system to then serve that distribution system that I talked about in the previous slide. So enough about us. What's the problems that we're here to talk about? We realize that Canada has an emissions challenge related to where we want to get to with our Paris commitments, and then obviously beyond Paris to some sort of lower carbon or net zero economy, which I would suggest is still being discussed in the halls of power in Canada, as well as in the policy halls of power. And so that's what I want to talk about. We're very aware and really looking at how we can help support this. And to take you on to the left side of the slide here, where it says Canada's 2030 target, in the orange bar where it says 86 megatons, within that is the federal clean fuel standard and the reductions of about 30 megatons that will come from the liquids and gaseous stream. And ATCO is an obligated party as part of that. So what we've done is say, okay, the government's sending us a message with this proposed updates to the CFS that they want to see that target, and how can ATCO and Alberta support this? To put those numbers in perspective, the government's looking for a 219 megaton reduction over, approximately the next 10 years. Just to put that in perspective, that's 207. Alberta's whole economy is about 277 megatons of emissions. And as you can see, the vast majority of those emissions come from either industrial or power generating sources, and then the rest come from transportation and building heat. So given that the government says we want to get to these 2030 targets, and then beyond that, past those targets and probably to, like I said, a net zero future, what is the transition pathway? And this is a slide that we've borrowed actually from the Transition Accelerator, or CSER, here in Alberta. We work closely with them and love to share ideas. And we really think it's likely that the energy system of the future is going to go to a place where hydrogen plays a big role. And we see low carbon sources of electrical energy growing as well. And then we've listed biofuels. And so within biofuels, that could be renewable gases, it could be other biofuels that are liquid fuels, supporting the liquids that we believe will still be needed in the future. But this is really where we think things are going. And so from that starting point, what have we done at ATCO, and what are we doing? So what I didn't show you in my first slides is we're an international company. We work all over the world, and we have a gas distribution system in Perth, Australia. So we actually built what we called the ATCO Clean Energy Innovation Hub. It went live in July of 2019, and what it is again, given Perth has great renewable resources, especially solar resources, we've been generating what we call a green hydrogen, a low carbon hydrogen, from the solar that we have on our site, and then storing it and using it to not only heat and power a hybrid modular home on site, but also to do hydrogen injection into the gas distribution system in that area. So that was ATCO's first kind of shot at, okay, what makes sense for Perth, and what can we learn from this? I'll talk a little bit more about where we're going to go to now in Alberta. So in Alberta, when we looked at kind of replicating that, we just said, hey, we think hydrogen makes sense for Alberta, but that technology fit, that technology solution doesn't make a lot of sense here. And the reason is we have different solar and wind resources here, and our electrical grid is obviously, it's not low carbon today. However, Alberta has amazing infrastructure for carbon sequestration, and it's built, it's operating, as well as it has some pretty significant hydrogen infrastructure today. So what we've done is we've put together a project where the project's been awarded. We've started engineering already, and we'll start construction early next year, where we blend hydrogen into the Fort Saskatchewan distribution system. So Fort Saskatchewan is a satellite community just outside of Edmonton. We're going to blend into about a system that has about 5,000 customers. It's going to be a very large blending project as far as the number of people impacted. And really what we're hoping to do is overcome. I mean, when Scott talked, he talked about the evolution there's been in BC around utilities investing in not only renewable or low carbon gases, but the innovation stuff. We don't have that yet in Alberta. And so really overcoming those regulatory, technical, and kind of business model type challenges of how this is going to work. Just to give you an idea, a gas utility in Alberta can't own a hydrogen pipe today. A gas utility can't make investments to lower emissions today, like just the way that the regulations are written. So we're working with the stakeholders here in Alberta to try and get those changes, and this project's the first step on that. So I've shown you some fancy projects, but what are the emission reduction potentials in Alberta? I think it's really important, given who's on this call, to just show you what they are and be open and honest about these numbers. So the proposed project, the first one you see, is that Fort Saskatchewan blending project. And these numbers are all in tons. So where it says like large scale Edmonton blending project, that's 1.6 million tons if you went 100% hydrogen. And this is hydrogen that would be made with carbon capture. So happy offline to talk to anyone if they have questions about the assumptions behind these numbers. But what I want to show you is the entire ATCO distribution system, because I think this is all about where hydrogen and RNG and everything we're talking about here is like, where can we get to? I want to be really clear that I don't think it's practical that every piece of the ATCO distribution system has hydrogen, pure hydrogen in it. That's not what I'm saying, but I want to show you what the possibilities are. And when I say that, it's because based on what we know today, but there is a future where a large portion of our system could have hydrogen in it. And my next slide, I'll talk about that, as well as some RNG, and maybe there's another solution that we're not thinking about for some of our customers. But the whole ATCO distribution system would be 12.4 megatons of annual emission reduction. And to put that in perspective, there was a carbon capture pipeline just completed in Alberta late last year. It has about 14 megatons of capacity in that pipeline. So that the infrastructure already exists to capture 100% of the emissions from our distribution system, should we choose to move to a pure hydrogen system in the future. And I think it's really important to note that in Alberta, we have the geology and the infrastructure already to make that happen. So that's something that I think is worth further discussion. And when I say that we're talking about, moving to 100% hydrogen systems, obviously, whether it's the Perth project that I showed you, the Clean Energy Innovation Hub, or Fort Saskatchewan, we're just getting going. But our intent is really to push the limits and understand what is, there's questions about just regulations and technology, and then there's a question about economics. But, as we look at all of these questions, what would it take to do this? So we're working on an internal study about what it would take to get about 80% of our network to 100% hydrogen. So can't share much more about that right now, but I just want to say that that's something we're looking at and we're working on. So finally, what are the barriers to adoption? I talked about them in some of my other slides, but there's really a lack of awareness in Canada about where hydrogen's potential is. And the reason that is honestly, hydrogen's been a specialty gas for industry, honestly, for the last 100 years. It's not something we've used to heat homes with. However, if you look back at the history of gas distribution systems and the first systems that were built, whether they're in the United Kingdom or even the system in Hong Kong is very old. The UK used to have well over 50% hydrogen in its gas up until about 1960. Hong Kong still has about 50% hydrogen in its gas today and operates safely and reliably. There's a lack of kind of codes and standards evolution in Canada around the issue of hydrogen blending, and it's because we've really never done it here. That's something we're working on with all the other people on this call and with the Canadian Gas Association and Énergir to figure out what needs to be done then. And then finally, appliances. Appliances are not set up today, so you can easily switch them over to 100% hydrogen. We believe strongly there needs to be some signal sent to appliance manufacturers if we're going to go down this pathway as a country to start building appliances today that are ready not only for hydrogen blends, but that we can quite easily change them to pure hydrogen should should we want to in the decades ahead. And finally, and most critically, I talked about it, for Alberta specifically, we need to make some changes to allowing utilities to invest in things like reducing carbon and responding to climate change and be able to recover those costs. I mean, Scott gave a great presentation where his utility is actually able to do that. Ours today is not. Finally, not everywhere is going to have carbon capture geology where it's easy to do in Canada and low cost production. We need to identify, I'll say, the nodes within Canada where that exists and figure out how we can leverage that for not only our environmental benefit, but our economic benefit. So this is my last slide. I know I only have 10 minutes, I'm probably over. So just, I think that what we're trying to say is Alberta is a great place to get this going. It's a great place to start because we have large industrial demands that are hard to decarbonize, and hydrogen can play a big role in that. We also believe that we're probably the lowest cost place in North America to produce the hydrogen. And finally, and I show this on the slide, there's no reason why we can't move that hydrogen around the country. And I show the provinces that have low carbon electricity grids, BC, Manitoba, Quebec, Ontario, and why they can't be a part of the production as well, using their low carbon electrical grids. So that's our vision right now, and I'll pass it off to the next speaker.
Thank you, Greg. That was really interesting. I'm sure there's going to be a lot of questions on that from our participants today. I'm just mindful of time, but want to introduce Vincent Regnault from Énergir, who will talk to us about what's happening with his organization and in Quebec.
Thank you very much, Tara. Do you see my screen well?
I do, thank you.
All right, excellent. So, well, first, welcome for inviting me and Énergir to participate to this webinar and give Énergir's perspective on the future of hydrogen and renewable natural gas in Canada. Very happy to be here. As you mentioned, I've been with Énergir for 12 years now, but with renewable gases for the last 3 months. So it's quite new for me, although I've always been very interested into this topic over time. But it's the first time I have the chance to talk about this topic for the company in the public space. So happy to be here. Two things I want to discuss very briefly, say a few words about Énergir, and then pass on renewable gases and our perspectives on these gases. Énergir is involved into many sectors, many areas in the energy sector, distribution, transportation, production, and other type of energy, other services. We have many assets throughout North America, some of them contributing to the energy transition that we're all talking about right now. I will be happy to answer any question later on if somebody has questions about these. Important thing, I think, for the webinar this afternoon or this morning, depending on the time zone you're in, our natural gas distribution network in Quebec, mainly located in the southern portion of Quebec, around Montreal, Quebec City. There's also a line which goes, the transmission lines which goes into Saguenay and Lac Saint-Jean. We crosses more than 325 municipalities, a little bit more than 200,000 customers, as well as more than 6 billion cubic meter we distribute on a yearly basis. So that's approximately 210, 220 BCF, depending on the year. Obviously, we're a public utility regulated also. This is the slide I call the 1, 2, 3 punch. This is, how Énergir answers to the energy transition that we're into. We're an active player of this energy transition in Quebec. That's our wish, and that's the decisions that we are taking. So first, we believe that the energy that you don't use is the best way to reduce the GHG emissions. So we work very hard with our customers to reduce their consumption through energy efficiency program. We also try to replace as much as possible petroleum products, either in heavy transportation as well as certain industrial processes. As some of you may know, We have a LNG facility in Montreal where we can liquefy natural gas as well as store it. And third, but not less, is we try to integrate as much as possible renewable gases into our system. If I turn now to renewable gases more specifically, you can see I show you here a map of Quebec where there is several RNG projects that we presently have into our pipeline. So you can see the blue dot between Montreal and Sherbrooke, which is the first operating project of RNG production in Quebec. It's in the city of Saint-Hyacinthe. They produce right now approximately 6 million cubic meter a year. And you can see that there's many projects under construction or under development. So this is something that we relying on to attain some GHG reduction, emission reduction over the next few years. I thought this would be of interest for the people in the webinar. 2018, there was a study made by the WSP, which concluded that there was the technical economic RNG production potential by 2030 would be equivalent to 144 petajoule, which is almost 2/3 of the natural gas that we distribute. That would represent removing 1.5 million cars off the road, or 7.2 megaton of GHG emissions annually. Obviously, you know, it will not be possible to attain that potential. There's many uses out of this 144 petajoule, but we expect that to be able to translate this potential into true deliveries in a significant amount. A couple of years ago, the Quebec government issued its energy policy. It set its GHG reduction target at 37.5% compared to 1990 levels, and it made a good place to RNG, either to increase it or to make it more available to our customers. And following the energy policy, there was an action plan which was also published by the Quebec government, which set a few goals in terms of RNG injection into our gas system. As you can see, 1% in the year 2020, which is basically our rate year, which begins tomorrow, October 1, 2020. There's a goal of 2% by 2023 and 5% by 2025. This slide shows the recent development in Quebec. I bring your attention on November 2019, where the Quebec government launched a 70 million provincial subsidy program for RNG projects. So many of the projects which are under construction or under development that you saw a couple three slides ago are funded partially by this plan. In April 2020, 45 million out of this 70 million was allowed to 8 RNG projects to have them inject into our gas system by 2023. And very recently, there was a 300 million program which was disclosed by the government for organic waste management, including RNG production. The big talk in town or in province, I should say now, is the Green Economy Plan, what we call PEV, P-E-V, which is the plan of the government to attain its 2030 GHG reduction targets. We expect that this plan will include a much larger share of RNG usage. It will also provide guidelines and details in order to give or allow the 25 millions that remain in the 70 million envelope I've talked about a few seconds ago. And we expect that there will be also other incoming assistance for RNG development. In order to attain this 5% goal, we expect that the first generation will allow us to attain that goal. But if we set more important goal in terms of RNG into our system and decarbonation of our gas system. We will have to rely on second and third generation of RNG, either produced through a pyrogasification or power to gas. And this is where hydrogen comes into play. We expect that hydrogen will be a necessary gas to inject into our system in order to attain much higher GHG emission reductions, either by blending it into our natural gas network or through dedicated pipelines. The first thing that we have to do at Énergir in this order, and in order to have some hydrogen into our system, is to determine what are the limits of the quantity of H2 that we are able to inject into our system. Our system was built mainly the 60s, 70s, and 80s. So there's still a lot of iron and steel pipe, which sometimes are not very suitable to welcome hydrogen. So we're working on this right now, really to determine these injection limits that our system can resist or accept. Last slide, a few hurdles that we're seeing with respect to hydrogen. So 4 types, basically commercial, social, technical, regulatory. I think that commercial hurdles, we all know a bit about this. Very high costs across the entire chain. Public investment is not enough right now if we are serious in using hydrogen to decarbonize our economy. And low emission hydrogen remains underdeveloped worldwide. I would take, social is an important thing in Quebec, as it is everywhere. But in Quebec, we've worked very hard over the last years to keep our social license to operate and keep this social acceptability of natural gas. And with hydrogen, it will be the same. We will have to work very hard to explain to the people what is this energy, what type it is, what are the true benefits of it. And we think that there will be a lot of work in this on this aspect to make sure that we are successful with hydrogen over time. Technical, I think that we all have the same have to tackle the same challenges with respect to safety, amongst other things, but very important, obviously. Leaks and integrity are very important too. Last sector or aspect of the hurdle that remained, it's regulatory. Speaking a bit about the current legal and regulatory framework, legislative framework for clean fuels, and also accelerate network upscaling and adaptation codes and standards. But one of the things which is really the object of many discussions internally is the regulatory aspect, how we will be able to fund the research and development that we need to do in order to inject some H2 hydrogen into our system, and how we will be able to recuperate those costs through our rates. I know that some other speakers have talked about this. This is an important aspect of this big puzzle in Quebec, and we will have to work very hard on this aspect, which is because of the law that applies to us, which is specific to Quebec. As everybody has a specific law that applies to the utility in its province, but in Quebec we will have to. This challenge is specific to us with the law that we have. So we will have to make representation before the government and make sure that we're able to have the necessary carve out to be able to fund and advance in this sector. So that completes the few words. I hope I was able to keep it at 8 minutes or so ish, and I will be welcome to answer any question in the future. Thank you.
Thank you, Vincent. And I know we're running a little tight on time, but without further ado, I'm going to switch to Sam. Samuel.
Okay, everyone. So thank you. First thing I want to do is just very quickly thank the technical folks who helped put this together. Everything seems to have gone smooth with the slide, better than in practice. So Oda, Tahara, and Stephen, thank you very, very much. And also, today's National Coffee Day. Buy yourself a coffee. If not, buy yourself a tea. If that's all you drink, nobody will know the difference. Good morning, good day, good afternoon, good night, regardless of where you're calling from. So what you're looking at is the agenda today. And what I want to talk about is Enbridge's perspective. So the general characteristic of the natural gas distribution network. I'll talk very briefly about the market in Ontario, talk about the GHG emissions reduction target, the outlook for hydrogen, RNG, and I'll touch on RNG on a much lower density than I will for hydrogen, and then we'll talk about the barriers for adoption. So when you think about the natural gas distribution system, think of it as a big battery. And the reason why I say that is because it'll become more clear as we move ahead. Think of it as something where you can use to connect, because of power to gas and renewable hydrogen, you hear a lot about it. We have the potential to store a lot in there. So I'm going to show you how vast this network is for Enbridge. So Enbridge pipeline, this is our transmission systems, covers about 38,000 kilometers across North America. We transport about 18 billion cubic feet of natural gas every single day across North America. And just the BC pipeline alone transport about 60% of natural gas produced in British Columbia. A little closer to home, if we look at the distribution system in Ontario, you know, again, a large, massive battery. Think of it that way. We serve about 3.8 million customers, and 75% of the homes in Ontario are fed by Enbridge's distribution system. We are North America's largest gas utility by volume, and we're the third largest by customer count in North America. Our network here in Ontario is about 145,000 kilometers of distribution mains and service lines. And we operate the largest trading hub for gas in North America. It's about 280 billion cubic feet of natural gas that we have there in storage. The big thing why I'm bringing this up is because of this third to last bullet. Power to gas and hydrogen is going to enable us to tie the gas network with the electrical network. And it enables things like non-dispatchables, such as wind and solar, to become dispatchable. No longer do you have to turn them off at 2 in the night or curtail them. You can run them, produce hydrogen, and you have that potential to store them. So just to give you an idea, Ontario would need about 60 nuclear plants on the worst day. Like on a peak day in Ontario, the gas network peaks out at about 81 to 84 terawatt hours. The electrical side of it is about 23. So that means you'd need about 16 nuclear plants running at 5 terawatt hour each to replace it. And this just reinforced what I say. So I'm not going to spend a lot of time on this, but this is to show you that the criticality of the natural gas network within the province, the reliability, and the cost effectiveness of it. And we see potential for this when you blend hydrogen in this system. So let's talk about our energy mix. We've been at the renewable energy for just over a quarter of a century, 25 years plus. We've invested $8 billion since 2002. We have about just under 2 gigawatts of long-term renewable power, and a lot of those are in our wind farm. We have a lot of offshore wind as well, and that's equivalent to producing power for about 900,000 homes. In between 2005 and 2016, in Ontario, we reduced emission by 21% below the 1990 level. So about 12.2 million cars equivalent we've taken off the road. So if you look at the GHG emission picture in Ontario, the 2018 target GHG emission for Ontario was 165 megatons. In 2030, the target for the province is 143. And the Made in Ontario Environmental Plan outlines this pathway, as you can see there. It touches on everything from low carbon vehicle uptake natural gas conversion, to the Ontario Carbon Trust. It looks at a whole bunch of things. But very quickly, you can see where the biggest ones are. The building has a large chunk of the energy, takes up a large chunks of energy, transportation, and the third one there is industry. So let's talk quickly about Enbridge's Power-to-Gas plant. So if you're not fully up to speed on what Power-to-Gas is, it's the process where you take preferably low carbon, clean electrical energy, and through electrolysis of water, you turn that into energy gas. And you may say, well, hang on a second, didn't I learn this in grade 11? You're absolutely right. It's exactly the same thing, but a little bit more complex, lots more power, etc. So here's a brief overview of our plant. The plant is a 2.5 megawatt PEM electrolyzer plant. It's on a very small footprint, 126 square meters. So think of it this way, it's literally our old garbage bin buildings that we've used. And my old partner, David Tadcrobe, used to say that. He said, it's our garbage building. Well, that doesn't sell very well. So we prefer to call it things like our bin building or something like that. So the project is, it's a joint venture between us and Hydrogenics. And Hydrogenics has been at the hydrogen game for over 70 years in the province of Ontario. The maximum output of the plant theoretically is about 1,080 kilograms a day. And if you look at it in cubic meter wise, it's about 12,000. And it can produce extremely pure gas, which can meet the SAE J2719 grade for motor vehicles. So here are our accomplishments to date. Number one, we demonstrated that the plant can produce hydrogen. We've demonstrated that we can store it. We've demonstrated that we can provide ancillary service to the ISO, and the ISO is the body in Ontario that manages the electricity grid. And if you're wondering what we do, we help them manage the frequency. Can't go more than about 1/4 of a hertz above or below, so we help to keep it at 60 hertz. What we're planning to do is we're going to look at things like renewable feedstock, transportation for fuel, and blending in the natural gas grid. And I'm going to talk about that right now. So I encourage everyone to, if you have the time, go on the Ontario Energy Board website. It's public document or filing to the board, and you can see it. We filed with the Ontario Energy Board to blend a small percentage of hydrogen into the natural gas distribution system. This is the area here. It's about 3,600 customers. We're blending up to 2% hydrogen, which is about 109 tons of CO2 abatement. And I did ask my guys, I said, hey, look, if we blend 0.5%, which is also in the evidence when you go and take a look, across the entire system, no holes barred, what would that look like? And it works out to about 50,000 tons that we would abate of carbon dioxide. Now, we know from past presentation prior to me that this is easier said than done, and doing that over the entire natural gas grid presents quite a bit of challenges, which we are working on, and we're well ahead of this. So how will we do this? Well, all I want you to take away from this slide is the prudency, the safety and resiliency that we've put into this. So the picture you're seeing here shows some of the tests we did on flame, color, fireplaces, etc., just to show you all that. So we did a very comprehensive review of the system before we were able to blend. This is a schedule for the application to blend. So the application, all the arguments in chief is now wrapped up. We've submitted our final argument to the board, and we're expecting to have a decision sometime in November or towards the end of November. Once that's done, the design is well underway for us to start construction, and we expect to be in service August 2021, by the end of August 2021. I want to touch briefly on renewable natural gas. This is not my...
We're running quite short of time, so I guess I'll give you a minute to wrap up, and if that's possible.
Sure. So with the renewable natural gas, really all I have to say here is that think of it as a circular economy. And on the right side there, we just got approval from the board September 2020 to allow us to offer our customers RNG supply on a voluntary basis. So these are some of the barriers. The cost of electricity is the highest for electrolysis hydrogen. Codes and standards must be nationally and internationally aligned. We need enabling policies from government, and we need to make sure that there's public awareness on choice. Electrification, as you'll hear, is not the only thing. There's a lot more to go. As a matter of fact, hydrogen alone can sustain 8% of the entire world energy usage. So with that in mind, I want to say thank you and open for questions. Take care.
Thank you very much, Sam. We've run a little short of time, but we're going to maybe go a few minutes over. Thank you very much for that really in-depth presentation. I think we're going to just go through a very quick poll, just 30 seconds or so, just to get everybody in the mode for the questions. So I think we'll have time for maybe 1 or 2 questions, and I'll just ask you to take a look at the poll, and we'll just leave it 30 seconds for people to respond. So we are getting some very interesting questions from our audience. There's a lot of technical things that we probably won't have time to go into today, but definitely questions that need to be answered in terms of blending capacity, what things need to be done in terms of upgrades to pipelines and like issues. So our poll is done. Our participants are really looking at we're looking at investing in green hydrogen, energy efficiency, and more RNG. So I think that's kind of clear going forward that Enbridge and ATCO and Fortis and Énergir are looking at those things as well. I'm just going to go into one question to start us off. In the discussions we've had so far, there's an understanding that there's a limited amount of RNG and green or low carbon hydrogen available now, and low blend rates in the near to medium term. How does your organization prioritize the use of hydrogen in RNG? And is there some uses that are looked at more than others, or is it possible? So I'll start off with maybe with Vincent to go to that question.
Sure. Well, thanks, Tara, for the question. You know, RNG is, I would say, one of the top 3 priorities of our organization in terms of, you know, answering to government call to and the society call to energy transition. We've been working on this not as long as Fortis did, but we've been on this topic since 2015, 2014, 2015. Start our discussions with the city of Saint-Hyacinthe, which is the first producer in Quebec. We've now have a dedicated team in order to develop projects of RNG. For us, you know, it's a no-brainer. You know, we have to invest into that. We have to make everything we can to increase the RNG production, show interest, bring interest from our customers, have some producer producing RNG. So this is, you know, it's unavoidable for us. It's that's the path to the future.
And Scott, do you have anything to add about prioritizing the use of RNG or hydrogen, and is that possible in your system? Very quickly.
Yeah. From the customer perspective, you know, we want to keep things in. We want an economic balance. So I would say, from the customer's perspective, those who are willing to pay for it and those who can benefit from it should use it first. And then in terms of integrating it on the supply side, obviously the less technical hurdles, the better. So RNG is easier than hydrogen, for example.
Okay. And Greg, is there any way that ATCO is looking at prioritizing the use for transportation or other uses, or is it just ubiquitous in the system and you'll try and blend as much as you can?
Yeah, so for us, our primary focus has been blending into our distribution systems. We don't have a large transportation focus right now. We would obviously love to help move along the transportation opportunity, but for us, we're really looking at how can we get these blends into our distribution system, and then ultimately figure out what it will take to potentially get to pure hydrogen systems. I'd also like to say we're focusing on distribution systems, so it's largely residential, commercial customers. We're not focused in on large industrial systems right now. So those customers generally are much more sensitive than residential customers to blends, and so that's the next step for us, and that's why I showed, I ran out of time a bit, with the distribution and transmission systems, and there's still some unanswered questions about how or if we can blend large amounts of hydrogen into transmission pipes because of the sort of customers coming off of them, like whether they're refineries, power plants, fertilizer producers, etc. So there's some unanswered question there. So that's sort of how we're prioritizing right now.
Great. And Samuel, I'll give you the last word before we wrap up.
Yeah, so for us, the good thing for us here at Enbridge is that we've been at it a little longer, and so we have a little bit of foresight than others on this. We have support from the highest levels within Enbridge, and we don't see hydrogen as the only game to get us to the GHG reduction. It's one of many that we see. I mean, we did a poll, which is also evident in the board filing, and 76% of respondents said they are interested in us using hydrogen for decarbonization. I mean, we see that coupled with DSM, electricity, electrification, RNG, IRP, SMR. There's a whole bunch of different things that needs to be done, but it's not a one size fits all. And so for us, hydrogen has a massive role to play in helping us decarbonize our grid. And we're looking at all the different opportunities.
Great. Any last words from anybody on this? Great. I apologize that we've run short of time. I just want to thank all of the panelists and participants for joining us today for part 2 in our webinar series. We hope that this presentation and our first presentation helped further the dialogue in this area. And as you can see, there's still a lot of unanswered questions about the role of gas utilities and blending of hydrogen and RNG. Pembina is keen to research them and bring groups together to work through the issues involved. And please get in touch with us at pembina.org if you would like to support our work with this important area. Thank you very much and have a great rest of the day.
Thank you.